Algebra 1, pace 1107, self-test today. Now, your study sheet mentions write ratios as common fractions and lowest terms. So when I say that, do you have something that pops into mind? Like, oh yeah, I know what that means. Solve for x in a given proportion. So you're missing one of the numbers in your proportion when you have ratios equal to one another. Solve word problems involving or dealing with a whole lot of things. Value of money and savings over time, proportions and comparisons, even perimeters, geometry stuff. Mixing things together, values of mixtures and percent mixtures. Asking for time required to complete a task. So when you got a couple of people, this person could vacuum the house in an hour. This person can do it in 5 minutes. How long have they worked together? Kind of problem. What else? When an increase in one variable causes a decrease in another variable and an inverse variation exists. So that's a lot of words for the inverse and the direct variation of things. Whenever something is, when one of your numbers increases, does it affect the thing it's equal to in a bigger way, or does it make it get smaller? That kind of thing. Well, that's the list. That covers the things that the PACE covers. Your job is to identify the areas that you need the most practice in. So there's a couple of questions you'll answer at the beginning of the self-test. And then you jump right into where it said writing ratios. What would you write for number 3 on the self-test? It says 1 hour to 90 minutes. So you're comparing 1 hour to 90 minutes. How would you write that in terms of a ratio?
Like 2/3. No, 60 over 90.
Yeah, your first thing would be to, okay, I have hour and minutes here. These don't match, so I need this to be 60 minutes. When it says 60 minutes to 90 minutes, then that creates your ratio, and then you write it as a fraction. 60 over 90. And right away, that's 6 over 9, but 6 over 9 can also be reduced to, what did you say it was?
2/3.
Yeah. 2 over 3. So number 3 is designed to be a simple problem just to get you thinking again about how to do this, because now you have to do it with some what looks like algebraic type expressions. But you still do the same thing. For number 4, you start by writing that first part, x squared minus 5x over 14, x squared minus 5x. Did I say over 14? It's supposed to say minus 14. Over x minus 7. Then you simplify. But simplifying this means you get to do some algebra. What do you see in this expression here? Are you able to factor that?
Yes.
Yeah. Meaning I need x and x something. I have 2 negatives, so that means I'm going to have what? A negative and a positive? All right, so a negative and a positive. What are the factors of 14 which combined or subtracted give me 5?
X minus 7, x plus 2.
Yeah, I think about 7 and 2. The difference of 7 and 2 is 5. And if the middle number is negative, the bigger number needs to be negative, so that is how I know where my 7 goes. And conveniently, look at the bottom. X minus 7 is down there too. So you can cancel these out, and you're left with x plus 2. And it's really x plus 2 over 1, but we're not writing it that way. But if we're comparing this as a ratio, it's x plus 2 to 1. Number 5, same thing, only you just write it.
Yeah, that one.
X plus 4 over x, and nothing to simplify. That was nice, right?
Yes, sir.
Number 6, we're supposed to solve proportions, and then you're also told additionally to check your answers. What you're solving means you're solving for a missing number. One of the values in your proportions are missing. So you're solving for that x, that missing value. So when you did number 6, what did you get for your answer? Right. Now what about number 7? So to solve this, what's your first step? What's your best first step to get x by itself, to solve your unknown, basically?
Well, you multiply 12 by x or reduce 9 over 12. But it will come out the same.
Yeah, the first step to solve this, no matter what the numbers are, would be to do that cross multiplication. So x times 12 gives me 12x equals, and then 9 times 3, which I know 9 times 3 turns out to be 27. Great. 12x. Wait a minute. This isn't going to go smoothly.
2 and a 4.
But I still have to divide both sides by 12. So x is 27 over 12. 12 goes into 27 2 times, but there's leftovers.
2.25.
Sometimes leftovers are good, right? You can enjoy it the next day. Leftover spaghetti, good. Leftovers in math, you just write it down. It's not necessarily good.
Does it want us to write the decimal or fraction of it?
Leave it in fraction.
Oh, okay. I wrote that fraction and then I put or and then I put the decimal just in case.
So you found this to be
2.
what?
4.
2 1/4, right? Is that what you got?
That's right.
Yeah, then you would check it by plugging that back in up here and cross multiplying again and solving. Number 8, now we have someone traveling. A motorist. Can anyone tell me what a motorist is?
Someone who drives something. Someone with a motor vehicle.
In a motor vehicle, yeah. So not something we might use on a daily basis, but you'll see it, if you're going to go take your driver's test, you might see the word motorist in there. I don't know. Do they use that word in their tests these days, or do they just change it to person driving a car or something? So yeah, motorist, someone driving a motor vehicle. They're traveling 228 kilometers. It took them 6 hours. At that rate, how long will it take them to travel an additional 247 kilometers? How would you set that up?
Well, 228 over 6 equals 247 over x.
Well, you can ask yourself some questions to help you figure out what to do first. You may already know what to do first, but if you're not sure, or you're really stuck, how do you get going? You read straight across, and you have motorists traveling, so you just kind of write down what you know. 228 kilometers. They did that in 6 hours. And the next section in that problem says, at that rate, which should lead you to ask the question, what rate? It almost seems like there's a rate that's been given to you that you maybe missed. Did you miss it? No, you didn't miss it. But how do you find the rate? I could use D equals RT. There's rate hidden in that equation. And there's the distance and the time. So 228 equals 6, which for time, times R. Divide by 6, and what do you get for R? Did you do it this way?
You get 48. No, 40.
41 1/3. Really?
38.
38? Check it. 228 divided by 6. 38. Look at that. 38 what? 38 kilometers per hour. Yeah, okay. So now we have a rate that we can use. And it says at that rate, how long will it take him to travel an additional 247 kilometers? So our new starting point is here. He's started here initially and drove for 228 kilometers. That's right here. So our new starting point is there. We need to go an additional, how far was it? 247? So the rate stays the same the whole time. So hitting this mark doesn't mean he stops and keeps going. He just keeps going. But once you get to this mark, it's like click. Hit a stopwatch and like, all right, how long to go another 247? And you can do the math and figure out, oh, our arrival time is going to be, nowadays we just look at our GPS on our phone and it tells you your arrival time is going to be, and you don't have to figure it. But we used to have to actually figure it. Hey, I'm going to get there. Mom, I'm coming home for dinner. Going to be home tonight. Looks like I'll be there at 7:30. Because you did the math on how long you're going to take to drive the distance. You're going at a certain speed. So our new D equals RT problem is 247. My rate we already solved for is 38. I need to now know the time. What time am I going to get there? How much longer? Divide by 38. And I find that my time is 6.5 hours. I'm going to take another 6.5 hours to go this far. So this distance was 6 hours. This distance is going to be 6.5. Make sense? Did you do the problem differently? Like maybe with a proportion? Did it work with a proportion?
Yes, sir.
Who knew? Interesting that there's multiple ways to do that problem. It would seem that the proportion might be a great way to try it, since that's what we're practicing with this pace. But here's the tried and true method for solving a problem like that. D equals RT, because you had a distance, rate, and time involved in the problem. All right, that was problem number 8. We forgot to write the 8 up there, but that was problem number 8, I think. What page was that?
Page 37.
37, indeed it was. Now we're on to page 38.
Oh, this page, what is it?
What do you see on page 38 that looks like it's going to be fun?
Definitely.
Oh, these are common problems. Ratio of a boy's age to father's age, 1:4. We have another 1:4 ratio. The sum of their ages is 35 years old. What are their ages? Well, which person do you know the least about? That's how we start a word problem. When you're doing this and you have no idea where to begin, which one do you know the least about?
I think you know the least about them both.
It feels like that. But you might say, well, I know that the father's age is 4 times the boy's age because I have this ratio, 1:4. So that means you actually know a wee bit more about the father's age than the boy's age. We have no idea how old the kid is, but we know the father's 4 times that. See how that makes the father something you know just a slight bit more about?
So the boy is just X and then the father is 4X?
So I would set it up that way. Boy is X, father is 4 times X. Because you've got that 1 there, 1:4. There's our ratio, and there's where it shows up in setting up the problem. We've been told that the sum of their ages, so if I were to write that out, sum of ages is 35 years old. Oh, I wrote it equals, so I was supposed to write is. is 35. So I write it in words first, especially if I'm really having a hard time setting my problem up, and then I turn it into a math problem based upon the words. Sum of ages. I know the ages is x and 4x, so sum of ages would be x plus 4x. Is equals, and 35. And now we took our words, turned it into a equation that we can solve. Now we combined these two into 5x equals 35. Divide by 5, and I'm left with x is 7. 7 what?
Years.
7 years old. And the next step is to find out how old the father is. So we're not quite done yet. We need to do 4 times 7, which is 28 years old. Now you would check it, of course, by adding, plugging this back in, and making sure you do your check, and it will find that it comes out correctly. Number 10, money problem. Money problems. These are very real life type problems, aren't they? The only way to not have money problems is just to not have money. An inheritance of $5,000. So that makes it sound exciting already. Who's excited about an inheritance of $5,000? It's more exciting than trying to figure out how old the kid is, right? It's going to be divided by 3 men in a ratio of 5 to 3 to 2. We have no idea how that was decided, but hopefully they're all okay with it. How much will each get? So this complicates our ratio a little bit, but it still works. We have that 5 to 3 to 2 ratio. So similar to how we did last time, in our last problem, we had each of these is an unknown, but it's an unknown by that amount. So one person is going to get 5 times whatever the unknown is, because we don't know how much they're getting. Another person is going to get 3 times whatever the unknown is, and another one's going to get 2 times whatever the unknown is. That way they would be getting this in a ratio of 5 to 3 to 2. Hopefully that part makes sense on how you'll set up a ratio problem like this. Then we put it into words. It's to be divided by 3 men in a ratio of 5 to 3 to 2. So another way to think about that is if you added what amount each person got together, you should get the whole total, which was 5,000. So I have 5x plus 3x plus 2x equals the total of 5,000. I find that if I combine these, I end up getting 10x equals 5,000. Any trouble with dividing 5,000 by 10? What do you get? X is 500. 500 what? Yeah. 500. That is the multiplier amount. Each person is going to get their share times this. So now we go back and solve for that. What's 5 times 500? 2,500. So it turns out he's actually getting half of the money. And these are splitting the other half. So what's 3 times that amount? 1,500. Again, this is all dollars. And 2 times that amount is 1,000. Then you will check that to see if they come out to the right total, and they do.
Are we supposed to check these ones? It just says solve.
Solve the word problems.
Check over these.
So if you don't have to do a check and you don't do the check, yeah, that's fine. You do want to, though, examine your answer just to be sure. Does this make sense? For example, if you had solved this and you made a mistake over here and they were, the total was $5,000 and you ended up getting, this person's going to get $25,000. Wow. Could that person get $25,000 when the total was only 5 to begin with? No. That wouldn't make sense. When if you made another mistake and maybe made it $250, then you would look at these amounts that are remaining like, boy, they don't add up to the total. Where'd the rest of the money go? Taxes. There's a lot of states that you don't have to pay an inheritance tax. So you can give someone a certain amount of money and they don't have to pay tax on it. But that's not every state. In some places you have to pay a huge inheritance tax, right? And we're learning about that. So hopefully these people are not in one of those states. For their sakes, because, someone left them some money, they should get it all. Now, don't give half of it to the government. Unless you're required to, of course. Then you have to do it. Number 11. We have a volume of 440 cubic meters. A volume of what? What's the shape?
Cone.
If you're looking at your formula, you see that your volume equals pi r squared h. And do you recognize that as the volume of a cone formula? Squared h? Or is that a cylinder?
I think it's a bowl.
A bowl?
Yes.
Well, I mean, it would be good to know. It's not terribly pertinent to the problem because they gave you the equation. Well, let's say they described the shape to you and didn't give you the formula. You'd have to come up with a formula on your own. You are told to use pi is 22 over 7 and radius is 5 meters. It gives you a hint. Transpose the formula before solving for h.
That's not a hint, that's harder.
So sometimes it's telling you to try that. If you didn't do it, then what does it look like to solve the problem? You have a volume of 440 equals pi, that's 22 over 7. You're given r, but it's 5 squared, and then h is here by itself. We're supposed to find h. We don't know what h is. I'm left with 22 over 7 still. 5 squared is 25. H, and still 440 here. What's my next move? What do I do next?
Maybe multiply 440 by 7.
Why would you multiply 440 by 7?
So that you don't have that fraction to deal with.
Yeah, you're trying to get rid of the 7 in the denominator. You could do that now, but you need to multiply both sides by the same thing if you were to do that. So this is times 7, and over here is also times 7, right? Because on this side, if I multiply this whole thing by 7, those 7s actually would cancel. And now I'm left with 7 times 440. What does that give you?
3080.
Okay, 3080. We're certain of that? 3080?
Yes.
Now I have 22 times 25 times h. What's 22 times 25?
550. Yes.
550 h. 3080. Okay. Well, now you have to divide by 550. And without a calculator, that's going to take you a while. But doable. Okay, what do we get?
We got 5.6.
So it simplifies down to 28 over 5, which then that becomes 5 and 3/5 is H. 5 and 3/5 what? Meters. You're just trying to find the height of that shape. You knew the volume. Okay, 5 and 3/5 meters. Nice. Problem 13 at the bottom, below the verse, has you being reminded about how a formula is affected, whether it's inversely or directly, as something changes. So that's the question you're being asked. And you do need to know how to answer these questions. So what would you say? In the formula r equals 113 over p, we say r varies blank as p.
Inverse.
It's inversely because p is in the bottom of the denominator, or the bottom of the fraction, the denominator of the fraction. And on the other side of the equation, the r is not. So as 1 gets bigger, in other words, as the p in that equation, as that would get bigger and bigger and bigger, think about that in your denominator in a fraction. As it gets bigger and bigger and bigger, your fraction is actually getting smaller. So r is actually getting smaller as p in that formula would be growing or increasing. So that makes it inverse. An inverse. All right, good. Number 14 asks you if m is halved, then a is what? So there it's a specific question. It'd be doubled. In number 15, a equals s squared. A varies directly as the blank of s. So, what are they asking you? They're telling you, describe in words what you see. So a varies directly as the square of s. That's the square of s. So pay close attention to that problem. Don't let that problem trip you up in the future. Just write down exactly what you see. Let's say that problem for some reason was a equals s cubed. What would you put in the blank? A varies directly as the cube of s. Yeah. So, number 16, a certain pipe can be used to fill a pool. Oh, we did some of these. You're pouring water into something, and sometimes it leaks out. A second pipe can be used to fill the pool in 4 hours. Now, wait a minute. This one doesn't have a leaky problem. This one has a filling it with 2 different sources problem. Remember the 2 different ones? So one way was you had a pool and you got water flowing into it, but it's got a small hole, so something is also flowing out, but not as much as what's going in. This one, though, is not that. This one we have where water is flowing in and more is going in. Is that right? How in the world do we set this problem up, though?
Well, you just do how many, like 1 pool filled in 2 hours, so whatever 2 plus whatever 4 equals 1 over x.
Does that make sense? Why you use that? Why the fractions?
I think so, because it's like you fill 1 pool in 2 hours, and you fill 1 pool in 4 hours.
Yeah, that would be a good way to word it, to remind yourself of how to set the problem up. I got 1 pool I can fill in 2 hours. Another pool could be filled in 4 hours with the other pipe. But if I combine their efforts, then what's the time? That's what I'm looking for. If I filled 1 pool at these 2 rates, what's the time I could do it is how you would set that problem up. So I want to find a way to simplify this. How might you do it?
You multiply by the LCD, which is 4, the two fractions that are added.
You could do that, but then you're still going to be left with an x as the denominator.
You multiply both sides.
Yeah, it's true, but you're still going to be left with an x in the denominator. Did you say you're multiplying by 4?
4x.
4x. Okay, sorry. Yep, 4x would do it because 2 goes into 4.
Why are we doing that?
We're just trying to eliminate all the fractions in one fell swoop. I can use 4x because the 2 is a factor of 4.
This just makes it almost a little bit more confusing.
If this was a 3, the 4x wouldn't help me. I would need to use 4 times 3, which would be 12x. But it's a 2, so if it's a factor, so if I multiply individually each one of these, 4x times 1/2 is going to leave me with what? 2x. Plus, and then 4x times 1/4 is going to leave me with what?
1 per x.
Just x. And 4x times 1/x is just going to leave me with 4. Because the x's will cancel there, 4 will be left. Combine these two, 2 plus x gives me 3x equals 4. So it turns out x is equal to 4 over 3. 4 over 3 what? What have I just found? Hours, right? But do we normally say 4/3 hours? No, we would say 1 1/3 hours. Well, actually, that's not exactly how we would say it, but if you're writing it as a mixed number, that's how you'd write it. All right, next, number 17. Here's where we got our combined work problem. A man can paint a certain home 5 days. If he and his brother can do the job together in 3 days, how many days would it take his brother to paint the house if he worked alone? How do we set that problem up? We got one house in 5 days. He's working with his brother, so we're combining the efforts with, we don't know how long the brother would take to do it by himself. So our unknown actually goes there. One house in unknown days, because that's the brother's work. If they did it together, 3 days. 3 days. One house in 3 days. So one house in 5 days for the man, one house in X days for the brother. Combined work is one house in 3 days. Now we just solve for that. Here, to get our common denominator, multiply something here to get rid of all those. I'm going to have to do 3 times x times 5 for 15x. 15x. I'm going to multiply 15x times this. I'll be left with 3x plus 15 equals 5x. Make sense so far? Let's see. Now we've got to get x by itself. Well, I can go ahead and just do minus 5x here. That's going to give me a negative. Negative 2x equals, and there's nothing left over here, so I need to subtract the 15 from both sides. So those negatives actually end up canceling each other out, so I'll have 2x equals 15, and x is 15 divided by 2. Or we would turn that into what, 7.5? 7 1/2 days. So the brothers would take 7.5 days to paint the house. The other man would do it in 5. Number 18. A man discovered he had only $5 bills and $1 bills. And he was panicking because you can't buy anything with $5 bills and $1 bills unless you got a bunch of them. Not today. Well, maybe he has several. He's been saving for a while. The number of $1 bills were 4 times more than 3 times the number of $5 bills. Did that help clarify anything for anyone?
Yes, sir.
It did? He had a total of $36.
Oh, we know at least
Oh.
about $5 bills.
Well, we know that he's in trouble because unless he's going to go out and eat by himself, you're not going to take anybody out to eat for $36 these days. Nonetheless, let's see. A man discovered he had 5 and 1s. Now, we got to ask ourselves the question again. What do we know the least about?
$5 bills.
Yep, because it tells us the $1 bills was 4 more than 3 times the 5. So that's a little bit more of a complicated way of saying it, but it's similar to back when we did the ages problem, where we had the boy, we knew the least about his age, and the father was 4 times the boy's age. This is like saying he's got 3 times the number of $1 bills as he does $5 bills, except it doesn't say that. It says 4 more than 3 times. But sometimes if it's too complicated to think about the 4 more or 4 less, just start with a simpler version and then add to it in your mind, or you can write it out. So $1 bills was 3 times the number of $5 bills. And then go back and reread it. $1 bills was 3 times the number of $5 bills. Okay, that makes sense. And then add the 4 back in. $1 bills was 4 more than 3 times the $5 bills. And now it should become a little more clear. So now I need to set my $5 bills as X and my $1 bills as what? What goes here? Well, it told you 3 times, but it said 4 more than 3 times. So that means 3 times plus 4, or 4 more than 3 times. That makes sense? I need to know how much he has total, or I need to know something else in order to set up a problem. They gave us a total, $36. So he has $1 bills combined with $5 bills. So these things combined, 3x plus 4 plus x is $36. How many of each kind does he have? Well, this will tell us how many 5s he has, and then we can find the number of 1s. If I combine these two, 3x plus 4 plus x, I get 4x plus 4 equals 36. Subtract 4 from both sides, and have 4x is 32. Divide both sides by 4, and x is 4 times what is 32? 8. So he has 8 $5 bills. 8 $5 bills. And here, to find the 1s, I have to plug 8 in there. So 3 times 8 plus 4. What's 3 times 8?
3 times 8,
24 plus 4 is what? 28. And everything seemed to be okay?
How does he have a total of $36? Because 8 times 5 is 40.
That's a good question. Eight. What did we do wrong? Anything?
I don't think so.
Let's look at our problem again. We forgot something important. Something's missing from our problem. What's missing? We have, think about how this was set up incorrectly here, because all this goes away. It was a good thought, but something's missing. This is a really, really common mistake on these problems where there's an item and the item has a value. So the value here is $36, but where over here is dollars? I don't have dollars equals dollars. I have number of bills equals dollars, and that they don't directly correlate. I'd have to know the value of my $5 bills. If I'm just counting individual bills, I've got $5 bills here, but I'm just counting them, 1, 2, 3, 4, and then I'm counting my ones, and unless I know they have different values, I'm not going to get $36 ever. So what's missing? How do I actually fix this? So that way I'll have a value associated with the number of bills. These bills are worth $1 each, so it's like $1 bills times that number will give me the total value of the $1 bills. But it doesn't really change it. What about here?
That's 5.
Yeah, I need a 5 there, because that's going to tell me the number of bills, and they're worth 5 each, is going to give me a total of $36. So a very common mistake made when setting up these money problems. Now if I solve this, it'll come out right, and we'll see we won't have the same problem we had before.
X equals 4, so there's 4 $5 bills.
Yes, so that'll change the outcome. So now you're going to have 3x plus 4 plus 5x equals 36, which is going to give me 8x. I'll subtract that 4. 8x equals 32. And now my x is going to end up being 4.
Now 5 times 4 is
And that will come out correctly. See, real important, if we didn't think about the check here, we would have just went on about our way and we would have got the problem wrong, because that's a really common mistake made with these. But you won't ever make that mistake, especially now that you've seen it. Right? That'll help you remember, because you had to do all that erasing. All right. And then we would continue on with number 18, 19, 20, and that concludes the self-test. So there's a few more problems that it would have been nice to be able to get to, but we didn't get to those today. So complete those ones on your own, and then you should be ready to tackle the test. So practice them. There's another money problem. There's another problem of solutions, mixtures. Yeah, okay, so we did 18. So only 19 and 20 left. We didn't get to those last two. So you got another money problem where you're adding up coins. That's one of those where you have decimals involved.
How do I find the number of each kind of coin on number 19? Because it doesn't give us more of one than the other.
Yeah, but you know the value.
Well, which one is that?
It's hidden in the problem. They called the coins quarters and dimes.
Well, which one is X?
Exactly. Do you know, which one do you know the least about?
I think we don't know any. No.
Yeah, that's true, because you know there's a total of 20. Total. And somewhere within that 20, there's some quarters. So 25 cents, and then some dimes, 10 cents. But we don't know how many of each. So we do know, though, that there's X quarters and there's 20 minus X dimes, because I know there's a total of 20.
So 0.25x plus 20 minus x?
Well, remember values. So we just did this in this last problem. So we have our number of quarters. So here's our quarters, 25 cents. And our 10 cents is going to equal, what was the total? $3.65. So I need to use decimals instead of cents. And how many of the 25 cents do I have? I have X of those. So 0.25 times however many I have is going to give me 365 when I go back and add it with the number of dimes I have. So I plus in my number of dimes. How many dimes did I say I had again?
20 minus X.
20 minus X. I don't know, but I do know that that's how many. Now my equation is written in terms of one variable, which I can solve for, and I'll get an answer. So that's how you set that problem up. When you solve it, you should find that you get a correct number of coins that when you add them up, you get $3.65. So 18 and 19, very similar problems, right? So you got to watch that whole thing there to make sure you don't make those mistakes. When there's values, that's what the money problems are tricky because of that. Any other questions? Now, one more problem to do. We almost did the entire self-test. It was pretty good timing. We worked quickly.